All right, in this last example, we're told that the probability that this weekend will be cold is 0.6. The probability that it will be rainy is 0.7. And the probability that it will be both cold and rainy is 0.5. What is the probability that it will be neither cold nor rainy? All right, well, the point of this example is to show you that you can use a Venn diagram with probabilities as well as actual numbers of things, right? These probabilities, you can think of this as 6/10, so 6 out of 10. So if you had 10 trials, then 6 of them would be cold. So, and this is 7/10. Or you could think of it as a percent. This 0.6 is 60%, so that's 60 out of 100, right? So we can just treat these probabilities as if they're the number out of 10 or 100, or we'll just do 1. So we can actually use a Venn diagram and use probabilities in a Venn diagram. Okay. So what I'm going to do is draw a Venn diagram, and the first circle is going to represent the event that it's cold. Okay. The second one is going to represent the event that it's rainy. Okay, and then we have our total or whole sample space here. And we know there's a 100% chance that something's going to happen, right? Now these two circles overlap because it could be cold and rainy. All right. And so let's go ahead and put the probabilities on our Venn diagram. So we know that there's a 0.6 chance of it being cold, right? So that's 60%. So I could change these all to percentages, but I just have to be consistent with whatever I choose to do. Since the numbers were given, it's decimals. I'm just going to keep everything as decimals. Let's see, it says there's a 70% chance or 0.7 chance that it's going to be rainy. And then there's a 50% chance that it would be both cold and rainy. So I'm going to put that in the intersection. All right, so now we can treat this just like a Venn diagram. So just normally, just the way we do any other Venn diagram. So I know that everything in the cold circle has to add up to 60%. So there must be a 10% chance, or 0.1 probability, that it will be cold but not rainy. Everything in the rainy circle has to add up to 0.7, right? So there must be a 20% chance, or 0.2 chance, that it will be rainy and not cold. Okay, and then we can see that the numbers inside the circles add up to 80%, or 8.8. All right, so then out here there must be 0.2, since everything has to add up to 100%, right? All the events in the sample space have to, the probabilities of all the events in the sample space have to add up to 100%, or 1, right? So if the probability that it's either cold or rainy, right, either or both, is 80%, then the probability that it's neither cold nor rainy is 20%, or 0.2. All right, so let's write that down. So the probability of being cold or rainy is essentially what I just calculated there, was 0.1 plus 0.5 plus 0.2, which gave me an 80%, or 0.8 probability. And what we want to figure out is what is the probability that is neither cold nor rainy, which is just the complement of that, right? So there's a couple different ways I could do that. I could use complementary counting, or I could just count it directly. So let's write this down. So cold or rainy, but not that, right? So I'm going to put a C around it. So I can just take 100% minus 0.8, which is the way I figured out what number to put out here in the diagram. And so I get 0.2. All right, well, that's all of the examples in this lecture, and I will see you in class.